This video is to assist students who are absent or are getting ahead in class who would like to go ahead and get started in the Earthquake virtual lab. All right, the first page it directs you to is a whole bunch of information about earthquakes and what are seismic waves and what's a seismogram, all things we talked about in class. So what we're going to do today is try to figure out where an earthquake happened. We're going to all do San Francisco together. So that's this example, San Francisco area. Submit choice. And then you're going to come down here. It's going to give you information about the S&P time, because remember, the further apart the S and the P wave, the further away the earthquake. View seismograms. Now we got to read these graphs really careful. Remember, your P wave always arrives first. So here's my P wave, followed by the more destructive, slow S wave. The P waves, they arrange, though, so they always arrive at 0. So when did my S wave get there? This one's getting there, looks like just before 50. So I'm going to put 48. Each of the lines across the bottom are worth 2, the little blue lines. So let's look at Elko. Here's, again, my P waves over here, my S waves over here. Find the S wave, follow it down, and we're looking at 72. And then we'll look at Las Vegas. Again, P wave, S wave, and S wave arrived 64 seconds after that P wave. Convert. You have to have read that graph very carefully. It's okay if you need to zoom, because if you're off, it's going to make you repeat it until you get it correct. So we did this same graph in class. So we want to find 48. So 48, we go across till we hit the diagonal and then go down. So that's really close to 460. 460. Oops, you can't see that right there. 460. Find 72 seconds. 72. Each of these blue lines for the time is 1. So 1, 2 is really close to 700. It's almost exactly on 700. Follow it across and follow it down. And then for Las Vegas, it was 64 seconds. So 64 is just 1 below that line there. Here. Really close to 620. So I'll put 620 in there. Find epicenter. And it says I'm very close. It drew all my circles for me. You see they all cross right here. So that's almost exactly where the earthquake is. The first thing you're going to have to do is you're going to have to take this picture. So I'm grabbing it. You got to take it and paste it into the document to turn your work in. This has to be turned in. I'm only casting one tab, so I cannot show you that process. But you need to copy this image and paste it into the Triangulation Lab document where it says paste circles here. Okay. Then it's going to ask us to just be like, okay, let's move on to the next part. Don't click any of these other buttons. We're going to go right down the bottom where we say compute magnitude, which is how strong the earthquake was. So the magnitude is how tall the waves were. So we're going to go to the next page.
Mr. Blaza.
Okay, I'm going to currently pause this real quick. And then we're going to use this device right here. It's called a Richter nonogram, right, to calculate how strong the earthquake was. So we're going to go to the next page. So we need to look at how tall the tallest wave was. So these waves are all pretty short. We're going to go to this S wave. Look how tall that wave is. I'm going to come up here. I'm like, wow, it's way the heck up here. So we're going to follow it across. Each of the blue lines on the side are worth 10. So 50, 60, 70, 80. I'm going to say that that is 280. 280. And then I'm going to come down here. These ones are a lot shorter because we're further away. So we're at 50, 60 because I'm looking at these tallest waves right here. They're just a little above 50. 60. And then for Las Vegas, that tallest wave is sitting right on that black line. So we followed across and it's 100. 100. Submit. And you see they all crossed right there at number 7. So my magnitude is 7. That's how strong the earthquake was. When they say it's a magnitude 7 earthquake, that's how they calculate it. And then when you're done, oh, I apologize. Let me go back one page. Oh, don't do that. Go forward. Oh no, it's yelling at me. Oh gosh. Please tell me it works. Okay, cool. When you're done, let me go. Let me go back and show this here. Please. Okay, good. This page here, you need to submit this image as well on your document. You just copy it or right click, copy, however you want to copy that image and paste it into the lab document. So I know you did this portion as well. And then when you're done, you go, my name is Drew Blazo, and my institution is E.E. Smith, and my city is Fayetteville. Fayettete. Fayetteville, North Carolina, and we're not going to put an email address in, and we're just going to get a certificate. And then you got to copy this certificate also into your into the presentation. So there's again, the earthquake triangulation lab, there's a spot for the certificate. Do that. So you got to turn in the circles, you got to turn in the Richter scale crossing thing, and you got to turn in the certificate of completion on that document. There's a Google document to paste it into. All right, that was our practice. Now for the actual assignment, you need to do the same thing for 2 other cities. So you can choose Southern California, Japan, or Mexico, but you have to go through and do 2 of them. If you do the 3rd, I will count it as extra credit, but you must do 2. Thank you very much, and I hope that you enjoy this activity.